Welcome back to the channel, everyone. In this video, I'm going to record myself analyzing this November 2021 Math AAHL Paper 1. I just recently got access to the entire November 2021 series, and I have already recorded some science multiple choices. I attempted those papers genuinely without looking at the questions or mark schemes before, because I think the genuine attempts will be very useful as the genuine attempts can outline my thought process in solving the question that I have personally not seen before. I'm not taking the same approach for this paper because I have already done the SL version of this, and that in turn is because some of my other students had access to the paper from their own school. I have since taken a look at the rest of the paper as well as most of the mark schemes, so I hope that this video will serve as a pure analysis video, and I think the approach that I outlined will still be useful, more useful than students just scrolling through the mark scheme. In any event, the first question here is a simple integration exercise because they give you the derivative, and the derivative is only in terms of x, so this is not like a differential equation situation where you have to like separate the variables. So if dy over dx is given, it's a linear composite of a standard function, because cosine is definitely a standard function which has standard derivatives as well as integrals. I use the term linear composite because the content inside the cosine is a linear function of x. So when you integrate cosine, you get positive sign. And in general, you need to multiply by 1 over the coefficient of the x term. But then here the coefficient is just 1, so there's actually no need to do anything other than just to rewrite the cosine as sine. You do need to include the constant of integration for sure, and the value of the constant of integration is typically found by just inputting the values of x and y into this thing. So 2 equal to sine 3 pi over 4 minus pi over 4 plus c. 2 pi over 4 is the same as pi over 2. And I trust you guys recognize at this point that sine pi over 2 is 90 degrees and sine 90 is 1. So the constant of integration is 1 as well. And the conclusion would just be y equal to sine x minus pi over 4 plus 1. So question 1 done. And yes, this question was also in the SL paper. And so is the next one, which is a question about graphing a reciprocal function. And that's already prepared. What they gave you? Y equals to 2x plus 4. And I'll rewrite the bottom as minus x plus 3, because lining up the x terms allows me to spot the ratio of the coefficient, which turns out to be the y equals to the coefficient of the leading, the ratio of the coefficient of the, the ratio of the leading coefficients turns out to be the equation for the horizontal asymptote. There are some limit arguments that you can use, but IB does not need any formal limit explanation on the reason behind horizontal asymptotes. The vertical asymptotes, meanwhile, is achieved when the denominator equals to 0. Just when x is, in this case, x equal to 3. And of course, there are reasons for it, because when you use x as ever so close to 3, the denominator is either a tiny positive number or a tiny negative number, which will cause y to approach either positive infinity or negative infinity. And that's a requirement for having an asymptote. I'll draw the asymptote first before I should have used a line tool, before I locate the intercepts. And the asymptotes are not supposed to be drawn using solid lines because the asymptotes are not The lines do not indicate function values. The asymptotes are nevertheless very important. It serves as the framework for the graph, which is arguably more important than the graph itself. If you don't have a good framework of the graph, then you won't be able to construct a nice graph. Before we construct the graph, we do need to address part B, which is about the x and y intercepts. X-intercept is achieved when y equal to 0. So 2x plus 4 equal to 0, resulting in x equal to -2. Y-intercept, you set x equal to 0 and y equals to 4/3, and you can also nicely read off the y-intercept value if you line up the x terms within the numerator and the denominator. And then now the general shape. You guys are supposed to know that the general shape of a reciprocal graph, linear reciprocal graph, is either this or the other way around. There are a few ways to figure out the orientation, but one way is just to locate the intercepts, and we can clearly see that this is the correct orientation. And I'll just switch color in time. So there's one branch. These kind of linear reciprocal graphs actually show diagonal reflectional symmetry, which I'll try to indicate, even though it's not a strict requirement. If you try to draw your graph to scale with proper proportions, then it will be easier to spot your own mistakes. But I think this drawing here should produce 2 marks. I guess you can label your asymptotes and intercepts as well. I'll just do so. And then there is a last part of the question wanting you to find the condition on A such that this related linear reciprocal function g of x is related to f, because everything is the same except the 2 within the f has been replaced by A in general. If you want to verify a self-inverse function, then you might want to find the inverse itself in terms of x and A, and then try to see what value of A would allow g of x to be equivalent to its own inverse. So just write it out first. It's ugly. So to find to find the inverse of g of x, what you need to do is what you can do is to replace g of x as y, and then you swap the x with y, and then you want to make your new y, which is your ox, the subject. And this kind of rearrangement should be trivial for AAHL students. And I'll multiply and then expand as well. 3x minus 4 equals to ay minus xy. Factorize and divide. I'll have 3x minus 4 over a minus x equals to y. And now I can claim, oh, that's ugly. G inverse equals to 3x minus 4, a minus 6. And this looks a little bit off, but what you can do is to just multiply the top and bottom. Do we actually need to do anything? Probably not, because I think all we need to claim is that a equals to 3. Wait, I'm pretty sure this is wrong because I've done it once before, and this should be a plus x. Okay. It's important to keep tracking your own mistakes throughout. Yeah, and then just not let your mistakes snowball. So like what I just did. I'm not going to cut this out. I think including mistakes in my video is important. Just you guys need to learn how to recover from mistakes ASAP. And this still looks a little bit off, but what you can do is times -1, -1. And you get -3x plus 4. That's how you get the plus, which is also in the original form. And I've got minus a minus x, and also that's how I also get the negative x in the target denominator. And now I think we can conclude that a needs to equal to -3. So that's the answer for part 2D. Question 3, log equation. So interesting that they give you two different logs that are not, they don't really belong to the same series. As in, like when they give you a log base 2, you expect to have log base 4, log base 8 elsewhere within the equation. They give you log base 2 and log base 3 as well, and it pretty much implies that you will have to use the change of base formula somewhere down the line. And because log base 3 seems to be more common throughout the entire question, I'll definitely change the log base 2 into log base 3 by using the change of base formula. Not changing anything else yet. Log 3 is just 1. Log 2 will end up being in the denominator, a numerator, my bad. And you can use like a series of log rules. Like for example, you can hide the half in front as a power of the 2, and then you have log plus log, which is equivalent to log of a product. And I'll just combine these two steps together. 2 to the half, I'll just write as root 2. And then now you have log base 3 equals to log base 3, so you can just take out both logs. So root x equals to root 2 times 4 x cubed. And if you clean everything up, I think you end up with this. X cubed divided by root x, well, root x being x to the half, and then you subtract the powers. So the right side becomes this. The left hand side is actually 1/2 to the power of 5. And then you can see that you basically have x to the, but this is what the left hand side is actually not x to the power of 5. The left hand side is actually root 1 over root 2 to the power of 5, because 4 is the same as 2 squared, which is the same as root 2 to the power of 4. And you may just take fifth roots on both sides. So 1 over root 2 equals to x to the half, and you can finally square both sides. So x equals to half. Moving on to question 4. Fairly standard tree diagram. So you have 50-50 in terms of picking box 1 and box 2 according to the question description, because you're just choosing a box by randomly. Getting red versus white, which is complementary to red in this case. Well, the top set probability is different from the bottom set probability. Should be 2 over 7. And then they're asking for P red overall in part A. Well, there are two ways to get red. So you can first, I end up picking box 1, and then you draw a red ball from box 1. So the chance that you draw a red ball from the first box is 1/2, meaning that you have to pick, you need to have picked the red box first, and then you multiply by the second branch probability, which is the second stage probability, which is always a conditional probability. And that gives you the overall probability for the entire top branch. And you do something similar for the next, for the third branch overall, if I call it the first, second, third, and fourth branch, fourth path, same thing. Here over the probability is 9 out of 14. Part B, determine whether the events are independent. There is a formula to verify independence. We need PA times PR to equal to PANR. So PA is the same as P1. So left-hand side equals to 1/2 times PR. We just figure out to be this. And then the right-hand side, PANR is not bad. PANR is just 5 out of 14, which is 10/28. So not the same, therefore not independent. There is actually a way easier and also way more fundamental way to verify if the events are independent. If A and R are independent, then P R should equal to P R given A, which should also equal to P R given not A, because the outcome of A should not affect the probability of R being true. And for this question, PR is this. PR given A is just a second stage probability, which is 5/7. And the PR given A, not A, is 4/7. So clearly these are not equal. Therefore, they are dependent events. Moving on, question 5 is about some calculus work without the full function information being given. The function defined and the line and a line with the equation y equal to 6 minus 1 is given to be the tangent at x equal to 4. So for part A, you have to recognize that the gradient of the tangent would correspond to the derivative of the original graph at that point. So therefore, the derivative value should simply be the gradient of the tangent, which is 6. And the next part, F4 itself, and students are meant to recognize that the tangent and the original graph are going to make contact at the point of tangency. And therefore, F4, the value of F4 should also be the same as the y value when you plug x equal to 4 into the tangent. And then now they give you a composite. They don't give you they still don't give you the F, but then they do give you the GX definition. So H4 now equals to F of G of 4. G of 4 is 4 squared minus 3 times 4, so 16 minus 12, which is still 4. And therefore H4 is still 23. The equation of the tangent to the graph of H at x equal to 4. We need to find H dash 4, and this will be a chain rule exercise because you need to find the derivative of the composite. So you need to differentiate F while maintaining the interior constant, and then you multiply by the derivative of the interior. F prime G of 4 is just well, G of 4 is that was still 4, so this F prime 4. G prime 4 itself, and I think we actually need to differentiate x squared minus 3x, which gives us 2x minus 3. So we have 6 over here times 2 times 4 minus 5 is minus 3 is 5. So the derivative is 30. I'll just write equal to 30. And then we can now do y equals to m x plus c. H4 is 12 is 23. M is 30. X value of point of contact is 4. So negative 97 equals to the y-intercept. So y equals to 30x minus 97 would be the equation of the tangent line. Okay, question 6 is now about some algebraic fraction leading to a trig equation. Show that should be some low-level question, like something that year 10s, year 11s can probably do. 2x minus 3 bracket x minus 1 minus 6. Expand the top, 2x squared minus 3x minus 2x plus 3 minus 6 all over x minus 1. Group the like terms on top, I think you'll just get this. The second part, I'll just copy and paste this because I don't want to rewrite all this. And clearly, there is a connection between part A and part B. You could have just let the x in the left-hand side of part A to be sine theta. And what you can do is to use this entire thing instead, of course, with x still representing sine 2 theta. So we have now 2 sine 2 theta squared minus 5 bracket sine 2 theta minus 3 all over sine 2 theta minus 1 equal to 0. And when they give you this kind of stuff, usually they're just being meticulous and making sure that you don't have a division by 0 situation, but then the theta minus not equaling to pi over 4 rarely has any direct influence on how you solve the problem. Now, moving on, when you have a fraction equal to 0, you're just basically equating the numerator to equal to 0. And this is a disguised quadratic, which you can factorize. I think it should be 1 and 3, but let me just finish writing. To get the negative in the middle, I think I need negative here and then positive over there. This one I get negative 6 sine 2 theta plus sine 2 theta, which is consistent with the minus 5 sine 2 theta. Sine 2 theta can never exceed 1, so sine 2 theta equal to 3 has no solutions. Instead, we have sine 2 theta equals to negative 1 over 2. The given range of 0 to pi would translate to become 0 less than 2 theta less than 2 pi, which is the standard 0 to 360 range. And if you use your unit circle knowledge, sine something equal to negative half means that something needs to be the third quadrant and the fourth quadrant versions of 30 degrees. So it's 210 degrees. Radian mode is 7 pi over 6. If I draw this on, this is the negative half. This is the 210, and then this is the 330. Of course, we have to use radians. And then we just finalize the answer by dividing by 2. So those should be the answers. Moving on, question 7. Was not in the SL paper. But this shouldn't be too difficult. I think this question itself is actually SL manageable. They give you a quadratic 3px squared plus 2px plus 1 equals to p has 2 distinct real roots. Distinct cannot spell distinct. That just means that when you use the discriminant, when you use the quadratic formula, the discriminant itself needs to be positive. But before we can use discriminant, we have to rearrange the entire equation and then classify each term according to whether is an x squared term or x term or a constant term. And I like to do this, just list them out. And then 1 minus p are both constant terms, so they will both belong to the C. And then we need b squared minus 4ac to be positive for 2 distinct real roots. As a result, we look at 2p all squared minus 4 bracket 3p 1 minus p bigger than 0, and this should develop into a quadratic inequality. Is 12p plus 12p squared, I think, bigger than 0. 16p squared minus 12p bigger than 0. You can divide both sides by 4, but I'll just leave it here. 4p minus 3 bigger than 0. And for a quadratic bigger than 0, we are basically looking for all the usually x value, but here it's going to be the p-value. You want to use p-value smaller than 0 or bigger than 3/4. P less than 0 or p bigger than 3/4. You can also use some other kind of sign diagram, but I think quadratic inequality is just best solved just by visualizing the quadratic graph itself. We'll just move on and do part B. They tell you p equals to 4. So this is just a matter of solving a quadratic, I guess. So p equals to 4 means that the original quadratic becomes 12. X squared plus 8x plus 1 equals to 4 means that you have -3 on the left-hand side. And then this is just a matter of using the quadratic formula. Equals to -8 plus or minus 8 squared minus 4, 12 minus 3, all divided by 2 times 8, which is 2 times 12. We do need to clean up the b squared minus 4ac. So you're looking at 64 minus -1/4, so that's 208. Bottom is 24. 208 has a prime factorization of 16 times 13, and 16 of course is a perfect square. And the final form also has a 13 sitting there, so I think it's quite obvious. I'll rewrite the 24 as 4 times 6 because a factor of 4 should be cancelable throughout. So a is -2. Surprisingly easy for question 7. Question 8, however, is big jump. It's still not that difficult because if you recognize that this is a first order linear differential equation, then you can just use the integration factor. I think it's called integrating factor. It doesn't really matter too much, and because the formula book actually has it, the integrating factor, which I'll just summarize as IF, is e to the integral of p of x dx. But of course, what is p of x? First of all, you have to rearrange the equation into this form plus p of x times y equals to q of x. So for the current question, what you can do is to move, I don't like the plus, the -2y/x to the left-hand side, making it positive. And I'll write it like this so that I can more easily identify what p of x is. Meanwhile, the ln 2x/x² is left on the right-hand side. So here the IF is e to the integral of 2 to the x dx. So this is e to the 2 ln x. And if we use exponent laws, then you can show that this equals to e, a log rules rather than exponent laws. So this is x squared. And once you have identified the integrating factor, what you have to further keep in mind is the need to multiply both sides of the equation by this integrating factor. Because by doing so, the left-hand side will look like the result of applying the product rule to something. The left-hand side actually looks like this. It looks like it looks like the result of differentiating x squared times y. And now you can integrate x squared y equals to the integral of ln 2x, my bad. Integrating ln x is a standard integration by parts exercise. The extra 2 in there is going to make things slightly interesting. So what you can do is to let u and dv over dx to be 1 and ln 2x respectively. And du over dx just 1 over x. Meanwhile, v just equals to x. And how do I know that this is a proper designation of u and v? Well, it turns out if you have experience, then there's a priority rule for like using integration by parts, like what functions you should tend to set to be u, which is the one that you differentiate, and what function you should integrate. There are many videos on this over the internet. Black Pen, Red Pen actually doesn't like it for some reason, I remember. I'm not sure whether Michael Penn talked about this. And there are a few other like famous math channels that discussed this before. But anyways, if we just apply this, you get x ln 2x minus 1 over x times x dx, because that's how you use integration by parts. And I think the formula is in the formula book as well. But as a math teacher, if I need to refer to the formula book, then I'm probably not qualified. dx x ln 2x minus x plus c. And now you can plug in the initial condition. So when x equals to half, y equals to 4, one equals to ln half equal to 0. Well, ln 2 times half is ln 1, which equal to 0, minus half plus c. So c equals to this. So I'm just going to be lazy and copy and paste all this. Good thing about doing math online is that you can copy and paste and save yourself a lot of writing sometimes. They do want you to make y to be the subject in the final form. Ln 2x over x minus 1 over x plus 3 over x squared. And let me check the answer, which is not being shown on the screen. Actually, I missed it too. That's why I checked the answers. On exams, you guys just need to be more careful. Don't be like me. Question 9, some binomial expansion that doesn't get tested very often. Binomial expansion with non-whole number coefficients is actually a new section within the current syllabus. So there aren't that many past papers, but if you can just go onto physics and math tutor and look under C4, because A-level, I think Edexcel A-level, in the old days, C4, which is like the 4th core paper, has a lot of this. That's a good place to find practices for this. Back to this particular question, I'm definitely going to rewrite the thing as 1 plus ax to the negative half minus 1 minus x to the positive half. And they tell you the binomial expansion has no constant term, and an x term with a coefficient of 4b, and an x squared coefficient, x term with coefficient 4b, and x squared with a coefficient of b, and b is some rational number, most likely a fraction. Most likely going to be a simultaneous equation situation, because that's a and b, but they also give you 2 pieces of information. So let's just apply binomial expansion for both brackets up to x squared. This is in the formula book, so if needed, then you guys can refer to that. But as a teacher, I am not going to bother. The next term will be negative half, negative 3 over 2, all divided by 2 factorial, which is just 2 a squared x squared. Make this wider, minus 1 plus half negative x plus half minus half over 2 factorial, which is just 2, and then negative x squared. And now just carefully clean these up. 1 minus a over 2 x plus 3 over 8 a squared x squared minus 1. Double minus, so this is going to be plus half x, and then we have a quadruple minus situation, so that's going to be still overall plus 1 over 8 x squared. And we can now group the like terms. 1 plus half minus a over 2 x plus 3 over 8 a squared plus 1 over 8 x squared. And now I think you can equate them to 4b. We can equate the 2 coefficients to be with 4b and b respectively. So half minus a over 2 is I think it's 4, which is 4b, so the front is 4b. While 3 over 8 a squared plus 1 over 8 equals to b, and I think I'll just plug this into there. Half minus a over 2 equals to 4 bracket 3 over 8 a squared plus 1 over 8. I'll just expand this. Equals to 3 over 2a squared plus 1 over 2. And the halves cancel, that's nice. So 0 equals to 3 over 2a squared plus a over 2. Factorize. I'll multiply by 2 and then factorize, so I think it's just a equals to 3a plus 1. Sorry, 0 equals to 3 plus 1, my bad. Times a, but the a does not equal to 0. And I think you can now conclude that a equals to negative 1/3. And if you put a equals to negative 1/3 back into either the equation, probably this one is easiest. So 4b equals to half minus 1/3 over 2. 1/3 divided by 2 is 1/6, but then you have to add that, so that's 4 over 6. So b equals to 1 over 6. So that should be part A, and if I remember correctly, I think this is correct. And yes, indeed, this is correct. State the restriction which must be placed on x for this expansion to be valid. So you've got 2 binomial brackets. If we scroll back up a little bit, for the expansion to be valid, we have to ensure that the thing that you're adding or subtracting, adding to or subtracting from the 1 itself is less than 1. So we have ax less than 1 for the first condition. So x is less than 1 over a, and a is negative 1/3, and this will translate into x is less than, well, absolute x less than 3. So negative 3 less than x less than 3. We do have a second binomial expansion to worry about, and the second condition would be absolute x is less than 1. So there's just negative 1 less than x less than 1. And overall, we have to choose x values that satisfy both conditions, and this is the harsher condition, which means that this will be the condition that the entire expansion have to satisfy. So that's question 9. Moving on, question 10 is some calculus kinematics. This question was in the SL paper. But I'll do it again, as I said at the beginning. Did I say at the beginning that I'm going to redo the SL questions anyways? Because I don't think the AAHL student would actually want to like watch my SL video. So here we have a VT relationship, which is a negative quadratic. Four plus 4t minus 3t squared, and it's actually factorizable. Without looking at the question, the first instinct is that you should be considering how to graph the thing. Turns out is this. The fact that they only give you a domain of 0 to 3 at the time should not prevent you from graphing the entire thing out. Again, you can now see that the maximum velocity is going to be this point, and you can either use completely the square or calculus. Negative 3 is not a nice coefficient in front, so I'll just resort to a calculus. So to find Vmax, you have to set dV over dt to equal to 0. So we're looking at 4 minus 6t equal to 0. So the time would just be 4 over 6, which simplifies to be 2 over 3. Show that the distance p from origin at this time is that. If you graph it out, then you can see that there's no change in direction yet, which means that you can simply integrate the VT relationship from 0 to 2/3. Had there been a change in direction and they ask you for the distance, then you have to integrate the positive velocity and negative velocity sections of the graph separately. Or you can integrate the absolute value of the graph. But then integrating the absolute value of a graph is not easy to do by hand. Here, I'm just going to integrate from 0 to 2/3, 4 plus 4t minus 3t squared dt equals to 4t plus 2t squared minus t cubed. Integrating a polynomial with 0 as a boundary is usually welcome, because when you plug t equal to 0 into the entire thing, all terms become 0. The same cannot be said when you integrate something that gives you like a cosine or like an exponential term, because either the 0 is 1 and the cosine 0 is 1, and those terms don't cancel. So that's something that you guys need to be aware of. But here I just have 8/9 minus 8/27, and have a common denominator of 27, I guess. So 4 times 2 times 9, 72, plus 24 minus 8. So I do get the 88/27. And then sketch a graph of V against U, and I've already done that before. Clearly show any points of intersection with the axes. In terms of VT is self-factorizable. 3t equals to negative 3t minus 2, 3t plus 2, if I remember correctly. But at the negative branch, the negative section doesn't really matter. Y-intercept, like the V-intercept is 4 and this is 2. So that should be the graph itself. And then part C is about finding the total distance. So this echoes what I said earlier on, because you can clearly see that the graph dips below the time axis after t equal to 0, indicating the graph has the object develops a negative velocity going back. The total distance, however, you will still need to, this is the case where you have to integrate. We have already had the integrated expression, and all we need to do is to plug 0 and 2 into the thing. So that's 8 plus 8 minus 0. Oops, 8 plus 8 minus 8. And that equals to 8. And then the backward distance is incurred during times from 2 to 3. And we fully expect the integral to be negative. So we look at 12 minus 18 minus 27 minus 8. With my bad, it should be plus. So that's how I make mistakes. So 30 minus 27 is 3. 3 minus 8 is negative 5. Absolute negative 5 is 5. Therefore, the total distance is 13. And I think that's question 10. Question 11 is AAHL stuff. Induction involving differentiation should not be the scariest type of induction question. So how to induction proof? Well, let Pn to be this. And the standard procedure for completing an induction proof is to verify P1 is true. So the first derivative, x squared times e to the x. So using, this is a standard product rule application. And then you have to verify that the right-hand side will give you the same thing. X squared plus 2x plus 1, 1 minus 1. And 1 minus 1 is 0. And I think you should end up getting the same thing. Therefore, P1 is true. The inductive step now involves the assumption that Pn is true for n equal to k, where k is some whole numbers. And I typically write, I'll just rewrite the original statement. The k, the xk, x squared e to the x equals to all this. We want to show that Pn is true for n equals to k plus 1. Another good habit, I think you should replace all the k's in the line above with k plus 1, just to see how the thing would look like. X squared plus 2 bracket k plus 1 x plus k plus 1 bracket k e to the x. Oops, wrong bracketing. And now we can differentiate the left-hand side. Or more like differentiate this one extra time. Just copy and paste. Dx of all this. And then I think you actually need to differentiate this now using product rule again. Just everything unchanged for now, because assume that we differentiate Ex first. And then we hold Ex constant, and then we differentiate the thing in front. And that's just a quadratic, which differentiates to become 2x plus 2k. While the k bracket k minus 1 is a constant, and that will disappear. And now it's a matter of regrouping the like terms. X squared plus 2kx plus 2x plus k squared minus k plus 2k. So you can see that I have expanded this a little bit as well. E to the x squared refactorized plus 2k plus 1 x. K squared minus k plus 2k is the same as k squared plus k. And of course, that can be refactorized to become the k plus 1k that we are looking for in the target statement. And of course, you have to write your concluding statement by the principle of MI. The original statement Pn is true for all n. For all positive integers. So that's the induction proof. Okay, and hence otherwise determine the Maclaurin series of this in ascending powers of x up to and including x to the 4. So what's the Maclaurin series like? So Maclaurin series of any function would correspond to f of 0, and this is in the formula book, but again, I'm not going to bother looking at it. You have f dash 0 over 1 factorial, which is just 1 times x, plus f double dash 0 over 2 factorial, which is just 2. Three factorial is 6, but I'll just write 3 factorial for now. F quadruple dash. I'll just do hence by using the induction result with n equal to 0, 1, 2, 3, and then 4 respectively. So what do we get when we have n equal well, f of 0 itself, 0 squared is 0, and then e to the 0 is 1. 0 times 0 is 0 times 1 is still 0. F dash 0. So this is the first derivative, so n equals to 1. But I think the square bracket content will equal to 0. The second term, n equals to 2 and x equal to 0. 0 squared plus 0 is still 0. But here you've got 2, n is 2, and then n minus 1 is 1. So we have a 2 in here, divided by the 2 factorial, which is a 2. That 2 looks ugly. And we still have an x squared sitting around. And by the way, e to the 0 is 1, and I should have brought it up earlier on. Next term, x squared plus 2x is still 0 because x is 0 when we're doing Maclaurin series. N is 3 means n bracket n minus 1 is 3 times 2, which is 6. 6 over 6 is just 1. So I'll just write this. And then lastly, n equals to 4. 4 times 3 all over 4 factorial is 12 over 24. So that should amount to half. And this should correspond to x squared plus x cubed plus next to the 4 over 2 plus higher terms. And I think it's important to have the dot, dot, dot. So only 3 marks. A lot of work though. Last question, hence or otherwise determine the value of that. You can just use the Maclaurin series, I guess. X squared e to the x minus x squared or cube divided by x to the 9 will equal to limit x squared plus x cubed plus x to the 4 over 2 minus x squared cube over x to the 9. So now the top just becomes x cubed plus x to the 4 over 2 all cubed over x to the 9. And I think this should just be a matter of taking the ratio of the leading coefficients. If you're not sure, then what you can do is just to do this perhaps, and then split the content 1 plus x over 2, because x to the 4 divided by x cubed is just x over 2. And this is clearly to be 1 plus 0 over 2 to the 3, and that's just equal to 1. So I think the mark scheme has many different ways, but I think this is one of the easier ones. Can you use L'Hopital's, which is something that students typically remember well because it's peculiar? Probably yes, but then this is a pretty high power fraction. So if you can find other algebraic techniques that can help you get there, by all means do so. Okay, last question is a complex number question. Consider the equation z minus 1 cubed equals to I. When powering and rooting complex numbers or multiplying or dividing complex numbers are involved, you probably want to consider the complex numbers in Euler form or polar form. Just the moduli and arguments can be very easily manipulated, whereas the Cartesian forms are not that easily manipulable during multiplication, division, and or powering and factoring, rooting. Here, I'm just going to keep writing z as z for now. The I on the right side, however, should be converted to be e to the I, and then the argument of I on the Argand diagram is just 90 degrees. Because the argument is like the unit circle angle. Pi over 2. And then when you take cube roots, you can just cube root the modulus. In this case, just 1. And cube root of 1 is still 1. What you can do is to divide the argument by 3 to get the principal angle. And then you have to recognize that the roots are equally spaced angularly. And when you have cube root, the angular spacing of the roots will just be 120 degrees apart. Well, actually, I draw wrong. That's definitely not 90 degrees. That's 60 degrees. Pi over 6, however, is 30 degrees. So that's what the 3 roots would look like had we been just solving z cube equals to I without a minus 1. With the minus 1, I think we just need to shift everything to the right hand side by 1 unit. I think that's what they want later on in part B, but let's not jump the gun. Z just equal to 1. They want you to find the other roots as well. And now just write pi over 6 plus 2 pi over root multiplicity, which is 3 in this case. So the 3 roots will just be pi over 6 plus 2 pi over 3 and pi over 6 plus 4 pi over 3 respectively. And I think I can clean those up. The 5 pi over 6, I think that one becomes, and the last one becomes 9 pi over 6, which is 3 pi over 2. Therefore, z will just equal to 1 plus each of them. One plus EI 3 pi over 2. And then to plot them on the Argand diagram, all I need to do is to shift everything. One real unit. Be like this. Just the length of each of these darker blue arrows are still 1. So this should be 1 minus I. And then if I try to maintain the approximate lengths. So those are the positions of A, B, and C respectively. And did they ask which one is which one? So this is A, this is B, and this is C. And then to find AC, so we have 3 vertices of an equilateral triangle. And I think you can just use some trigonometry, or there are many ways to figure this out. The official answer key requires you to just find the real and imaginary parts of AC, and then you use distance formula or something. I'll probably just use trigonometry with annotation. I'll do AB first because AB is horizontal. Because that's going to be 60 degrees. This is 1. AB is just equal to 2 sine 60, I think. 2 times, well, 1 sine 60, which is just root 3. And then because you are looking at an equilateral triangle, therefore HG should also equal to root 3. Just verifying my answer. Yes, that's correct. Last part, consider the equation that equals to that. By using de Moivre's theorem, which is actually what we did already in the first part, so I'm not sure why they bring this up again. Z minus 1 cubed equal to I Z cubed. So you definitely want to move the Z to the left side first and then just cube the entire fraction equals to I. So we have the same situation before, because when you cube it I, one of the answers is just E times I to the pi over 6. And you can try to make Z the subject. I think I'll just split the fraction here. 1 minus 1 over Z equals to that. Cross subtract. And then just take reciprocal both sides. Z equals to 1 over all this. And now they want you to find the real part of this root. We can just let alpha satisfy. And just to like communicate our answer more nicely. And then to find the real part, you have to rationalize the right-hand side first to make sure that you have a real denominator. And for the right-hand side, you do need to rationalizing means that you have to convert the denominator back to Cartesian form. Cos pi over 6 is 30 degrees. Well, that's 30 degrees. I'll probably just cos 30 is some ugly third expression, so I'll probably just leave it like this. And then use trig identities later on. And when you rationalize, you always get something like this. Actually, I won't skip step. I'll just copy the thing. And no, I'm not finding the real part yet. I'm just rationalizing. So to rationalize, you want to retain the same sign for the real part, but you want to flip the sign for the imaginary part. So the entire thing, using difference of squares at the bottom, you have 1 minus cos pi over 6 squared plus sine pi over 6 all squared. Whereas the top is just 1 minus cos pi over 6 plus I sine pi over 6. And I'll just drop the imaginary part at this point. So 1 minus cos pi over 6. And when you expand the bottom, you'll have 1 minus 2 cos pi over 6 plus cos squared pi over 6, which will become 1 when you add that cos squared pi over 6 with sine squared pi over 6. Now I think you have to rationalize. There's 2 minus root 3. Well, actually, the 2 minus root 3s are identical, so they cancel out nicely. And half is the final answer, and I think that's the correct final answer. Yes, indeed. All right, so there we go. So that's the entire HL paper, and I hope the analysis makes sense. if I have time, then I may try to do the second paper, but I have never recorded myself doing the second paper because using the GDC on the screen is not. I have the TI-84 downloaded as a laptop app, but I'm not very good at it. So I may practice a little bit more before I upload the second paper. And all right, thank you for watching and see you guys next video.